Bismillahirrahmanirrahim. Assalamu alaikum. Today we will cover Gre1777 Question 7 Thermodynamics. Which of the following is true about any system that undergoes a reversible thermodynamic process? A. There is no change in the internal energy of the system. B. The temperature of the system remains constant during the process. C. The entropy of the system and its environment remains unchanged. D. The entropy of the system and its environment must increase. E. The net work done by the system is zero. A quasi-static process is one that occurs slowly enough for the system to remain in equilibrium throughout, which is necessary but not sufficient condition for the process to be reversible. While reversible processes must be quasi-static, not all quasi-static processes are reversible. The conditions for the reversible process are: number one, in a reversible process, all system must be in state of equilibrium at all times, therefore must be quasi-static. Number two, reversible processes are an idealization. Number three, there is no loss of energy due to friction, heat dissipation, or other dissipative forces in a reversible process. Number four, a reversible process is a process in which the system and environment can be restored to exactly the same initial states they were in before the process occurred if we go backward along the path of the process. If an ideal gas is confined by a frictionless piston with internal pressure and internal volume, if external pressure is equal to internal pressure, the piston will not move. If the external pressure on the piston is less than internal pressure, then the ideal gas inside the piston will expand and the final volume will be greater than initial volume. If external pressure is greater than internal pressure, then gas will be compressed and the final volume will be less than initial volume. Boyle's law states that at constant temperature and for a fixed amount of gas, the pressure and volume of a gas are inversely proportional. We can show this on pressure volume graph. Work done is the area enclosed by the closed loop on the pressure volume diagram. If we compress the piston in steps, we notice that as the number of steps increase, the series of rectangles more closely approximates the smooth curve of a reversible process. If the number of steps approach infinity, we obtain a reversible process. For the reversible process, if the temperature is constant, QAB is equal to minus QBA, where Q is the heat exchange. This means that for the system and its surrounding to return to their original states, the heat absorbed during the forward process must be released during the reverse process. The work done in the reversible process is greater than work done in multi-step, which is greater than work done in one step. Entropy represents the portion of system's energy that cannot be used to perform work. High entropy means energy is more disordered or dispersed, while low entropy means that energy is more ordered or concentrated. According to second law of thermodynamics, the total entropy of the system either increases or remains constant, it never decreases. The infinitesimal change in entropy ds of a system during a reversible process is equal to the infinitesimal heat transfer dq divided by absolute temperature T at which heat transfer occurs. Therefore, ds is equal to dq over T. ds is the infinitesimal change in entropy, dq is the infinitesimal heat transferred, and T is the absolute temperature. If we integrate both sides, we obtain delta S is equal to integral of dq over T. For the reversible process, the combined entropy of the system and its surrounding does not change over time. If an irreversible process occurs in a closed system, the entropy of the system increases. Therefore, the correct answer choice is C. The entropy of the system and its surrounding remains unchanged for a system that undergoes a reversible thermodynamic process. May Allah bless us all. Thank you for watching. Allah Hafiz.